Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about the applications of the auxiliary planes to evaluate the true shape and sizes of the inclined cut surface sections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have got a solid for which the isometric projection construction is available with us, and this is the direction of viewing the solid from the front view, and from this side we are going to observe the solid from the right hand side view. Now here we have got an inclined cut surface section of the solid over here, which happens to be surface A. So this surface of the vertical web of the solid has been cut by an auxiliary inclined plane, and we are left with this inclined surface A over here, right? So this is the sectioned surface of the solid which has been marked as face A. So we are required to evaluate the true shape of this inclined surface A in the auxiliary view projections. So here we have got the solid, and if we look at the solid from the front side, we are going to observe the edge view corresponding to the section surface which has been marked as face A over here. So we get an edge view in the front view. So again, it is not going to provide us with the true shape of the surface A. When we look at the surface A from the right hand side view, so we observe that this surface A, which happens to be inclined to the profile plane as well, so this surface will be projected as a foreshortened surface or an apparent shape surface onto the profile plane. So we cannot obtain the true shape of the surface even in the right hand side view. Similarly, if we plot the top view corresponding to this solid, again this surface A, because it happens to be inclined to the horizontal plane, so again in the top view, that is on the horizontal plane, we will not be able to evaluate the true shape of the surface A. So we will be able to obtain only the apparent shape of the surface A onto the horizontal plane in the top view. So whatever three orthographic projections we are going to draw, we will be able to obtain either the edge view of this inclined section surface, or we will be able to obtain the shortened view or the apparent shape corresponding to this face A over here. So we have to use the principles of the auxiliary plane method in order to evaluate the true shape of the surface A. And the procedure will be, we are going to start with the construction of the orthographic projections of the solid, that is front view we are going to draw first of all. And once we obtain the front view, so the front view we can check, it is available over here. And once we draw the front view corresponding to the solid, we observe that this face A or the sectioned inclined cut surface, it will be appearing as an edge view in the front view, whereas in the right hand side view, because the surface A, it happens to be inclined to the profile plane, so we'll be able to obtain only the apparent shape or the foreshortened view of this face A onto the profile plane. So this is an apparent shape which has been obtained onto the profile plane in the right hand side view. So now we are going to draw an auxiliary inclined plane which will be parallel to the surface. That is our new auxiliary inclined plane. This will be parallel to this face A. And once we draw an auxiliary inclined plane parallel to this face A, then the projections of these 4 points of the face A onto the auxiliary inclined plane, they will be providing us with the true shape of this particular inclined section surface of the solid. So let us proceed with the construction of the orthographic projections of the solid. So we are going to start with the construction of the front view as well as the right hand side view of this particular solid. Now since we have to draw the right hand side view of the solid, so this right hand side view will be constructed onto the left hand side of the front view, and front view will be constructed above the XY reference line. Similarly, the right hand side view, it will also be constructed above the XY reference line. So the intermediate, we have got this profile plane, that is X1, Y1, and we have got this reference line as XY reference line. Let us proceed with the construction of the right hand side view and the front view corresponding to this solid. Now when we look at the solid from the right hand side, so we observe that over here we have got the depth of the solid, it happens to be 80 millimeter, while the height of the solid, it happens to be 70 millimeter. So we have got the right hand side view face, it will be having the dimensions 80 millimeter will be the depth of the solid, and 70 millimeter will be the height of the solid. And once we draw this height of the solid over here, so this is the rectangular face which is corresponding to the right hand side view of the solid, which is going to contain or present all the elements of this particular solid from the right hand side. And this height of the solid, we are going to project from this right hand side view onto the front view also, because in the front view again we are going to require two dimensions. The first dimension is width of the solid. So as we can check it out over here, the width of the solid happens to be 80 millimeter and height will be 70 millimeter. So height we have already drawn in the right hand side view. Now we are going to mark the width of the solid over here. So this is the width of the solid, which is equal to 80 millimeter. And we can check out over here when we are going to look at the solid from the front side. So we can divide this 80 millimeter width into three components over here. Then we have the vertical web at the rear side of the solid, which is going to have a rectangular slot over here. So this is a rectangular slot which we are having, because the dimensions of this rectangular slot, it happened to be the width, it is equal to 30 millimeter, and here you have the height, it is equal to 25 millimeter. So this is a rectangular slot which has been cut in this vertical web which is lying on the rear side of the solid. So this 80 millimeter width of the solid, we have divided it into three parts over here. So these are two portions of the vertical web which are available with us when we are going to look at this web from the front view over here, right? And the certain portion of this web will be covered by this inclined vertical web which has been sectioned with a section cutting plane, that is with an auxiliary inclined plane. So we are going to now have this particular slot which is going to measure 25 millimeter from the top. So this way we have measured the slot, and I can mark this slot over here. So this slot I have marked as, that is width, it is equal to 30 millimeter, and the height of the slot, this will be 25 millimeter. Now next thing is, when we are going to look at the solid from the right hand side view, so once again we can observe that we can divide this depth of the solid into three parts. So here we have got, looking from the right hand side view, we have the inclined section web over here. Then we have this well portion, or we can say this is a horizontal web which is lying within the two vertical webs over here. So this vertical web happens to be an inclined or the section web. This is again a vertical web which has got a rectangular slot cut into it over here. So these are the three portions of the depth of this particular component. So the first portion is the inclined vertical web which is having the depth equal to 25 millimeter, whereas this well portion or this horizontal web portion, it is going to measure 30 millimeter depth over here. And the final vertical web which is lying on the rear side, it is having the depth equal to 25 millimeter. So these three components, they have been drawn from the right hand side over here. When we observe the solid from the right hand side and observe different elements over here, so we work out that, so here we have a slot over here which is going to run through the entire depth of the solid over here. So this slot will not be visible to us from the right hand side view, so this has to be drawn dotted. So the height of the slot, it is equal to 10 millimeter from the base. Then at a height of 15 millimeter above the slot, so we have got this total height is equal to 25 millimeter. So at this height, our inclined web, it is going to end over here. Whatever sloping web we have, so it is going to end at this particular point. Further, this horizontal web, this height will also be equal to 25 millimeter from the base. And then we are given that this portion, it is also equal to 20 millimeter. So this portion is equal to 20 millimeter. So we can say that this portion is 25, this portion is 20, and this portion is 25. So height also we have divided it into three parts, right? So this height of the slot from this portion, it happens to be 25 millimeter. Then this height, it is equal to 20 millimeter, and this height, it is equal to 25 millimeter. So we have got 25 millimeter. It is the height corresponding to the element number 2. If we say this is element number 1, this will be element number 2, and this is element number 3. So corresponding to element 1 and element 2. So this height will be relevant to both of these elements, right? So this height we have marked as 25 millimeter. And once we mark this height, so I can draw a horizontal projection line starting from the front view, and I'll take it forward onto the right hand side view. Now next thing is, once I have obtained this point, that is this section over here, so this portion has been reached. Once I draw the edge view bottom point, now the top point of the edge view, it was already obtained at a height of 70 millimeter from the base over here. So this way, this point, it has been achieved at a height of 70 millimeter. This point has been obtained. Now I'll be able to draw the inclined surface edge view over here. So this is the edge view corresponding to the face A, which has been sectioned by an auxiliary inclined plane. Now once I draw this particular, you see, edge view, what's going to happen? It is going to cover certain portion of the rear web. So this portion of the rear web, which is not visible to the observer while the observer is going to look at the solid from the front view. So this portion will be drawn as the dotted portion, and besides this portion of the vertical web, which is the rear vertical web, this will also not be visible to the observer. So only the upper portion of the rear web, so this is the rear web, only the upper portion of the rear web will be visible to the observer. So this portion of the rear web we are going to darken while we draw the final orthographic front view projections of the solid. But for the time being, we have drawn only a construction line over here, which will be representing the edge view of the section cut surface A over here. Okay, so this completes the projection of the front view. And another thing we need to remember in the front view projections, that this surface which is lying over here, this will not be visible to the observer, right? So this portion will not be visible to the observer. So this we are going to draw dotted while we are going to complete the orthographic projections. Now the next thing is that we know that the height of this particular slot, which is an angular slot which happens to lie in the bottom web. So this is my bottom web over here. So in the bottom web we have got an angular slot. Now the height of the slot happens to be 10 millimeter. So once we mark 10 millimeter height over here, now I can draw this particular slot over here. And another thing I need to remember, please check, this slot, it is going to have this angular cross section in such a way that this slot is located centrally alongside this width of the solid, which happens to be 80 millimeter. Okay, now this point, that is the bottom point of the slot, will be lying at a distance of 20 millimeter from this end, and this point, that is again the bottom point of the other end of the slot, it will also be lying 20 millimeter from the other end of the solid while we are looking at the solid from the front view. Now this distance between the two bottom points will be 40 millimeter, and the top points of this angular wave, they are separated by a distance of 60 millimeter. So what we are going to do, we'll mark the distance of 40 millimeter over here, take these points up, and then 10 millimeter back side and again 10 millimeter on the front side will be moving, so that the top portion of these 2 points corresponding to this slot over here, they will be obtained onto this edge over here. So please check, I have marked this edge over here, and this distance I have marked as 60 millimeter. So once I mark this as 20, this is 40 millimeter, then once we evaluate the center, from the center I can take 30 on this side or 30 on this side, or else what I can do, from this point I'll take 10 millimeter back this way, or from this point I move upward and then I am going to move 10 millimeter forward, so that the top points of this angular slot which will be visible to me in the front view, they can be obtained. So in order to complete the right hand side view, so we can check this slot. As we were talking about, this slot, it is visible to us in the front view, but this slot, it is not visible to us from the right hand side view. So this will be drawn as a hidden line or a dotted line in the right hand side projection. So this dotted line I have drawn over here. Next, once we move on to the right hand side view, so we can see that there are 3 segments of this particular right hand side view. So the first segment, it belongs to the inclined surface A, which is corresponding to the section web which we are going to have on the left hand side. So corresponding to this face A of the solid, we are going to obtain this rectangular projection, which is nothing but it is the apparent shape or the foreshortened view of this bigger surface, which we are going to refer to as face A of the solid, right? So this bigger surface will be appearing as a foreshortened surface in the right hand side view. Then we have this well section over here, or a flat horizontal web over here. So this horizontal web has been represented over here as a dark line, right? This is the projection of this portion of the solid, and then here you have the vertical web. So we can see that this vertical web, this is integrated with the base web over here. So this I am going to join dark, that is this portion, this portion, this portion, this portion, and this portion. So I will be getting an L-shaped portion over here, right, corresponding to this surface of the solid. And then last thing which is left over here, it is this slot over here, which is a rectangular slot. So I know the corresponding rectangular slot which is available over here. So this is the position of the horizontal surface of the slot. This is the horizontal surface of the slot. So this will be projected onto the right hand side view using a dotted line projection over here. So this surface has been projected onto the right hand side view using a dotted line projection. So with this, we have completed the right hand side view and the front view orthographic projection construction for the solid. But now we are required to join the elements or the edges which are visible to the observer. Now I will be going for the darkening of these edges. So as we are going to look at the solid from the right hand side, so we observe that, as I have explained to you, this is the bottom web which has been integrated with the rear vertical web of the solid. So we can check, this is the bottom web which has been integrated with the rear vertical edge of the solid, and it has got a rectangular slot which is not visible to us from the right hand side view. So this will be projected as a dotted line in the right hand side view. Similarly, this is the slot which is an angular slot which happens to lie on the base web or into the base of the solid, and this slot, it is going to run through the entire depth of the solid. But this cut or the slot, it is not visible to us from the right hand side view. So we have to draw the dotted line projections corresponding to this slot, which is not visible to us from the right hand side. Now let's move on to the front view. In the front view, we have got this projection, we can see corresponding to the front web. We are able to see this portion. This one, it is visible. This edge, it is also visible. This portion, this is visible to us from the front view. That is the front web. We can check. This is the front web. This face, it is visible to us. So this portion we have already darkened. Then after this, we are not able to see this well portion that is corresponding to element number 2 in the front view. So this portion which is corresponding to the well or the horizontal component or the horizontal web, we can say, so this is not visible. So at a height of 25 millimeter, I am going to draw a dotted line in the front view. Similarly, we have drawn the projections for the rear web, which is a vertical web having a rectangular slot. So once we have drawn this vertical web, now we have observed that certain portion of this web, it has been covered by this sectioned inclined web which is lying in front of this vertical web, and the remaining portion I am going to draw as an object line or a darker line over here. So with this, we have completed the construction of the orthographic projections of the solid, and we have evaluated that there is one face of the solid which has been sectioned by the auxiliary inclined plane, and we have shown the shaded portion as the right hand side view projection of this particular face onto the profile plane, and this is the apparent shape or the foreshortened projection of this face A onto the profile plane. Now we are required to evaluate the true shape of this inclined surface which has been represented as an edge view in the front view. So since we have been able to obtain the edge view corresponding to this face A, now the true shape we can evaluate by drawing an auxiliary inclined plane x2 y2. This auxiliary inclined plane will be parallel to this edge view of this cut section. So this is my cut section surface. So I have drawn an auxiliary inclined plane x2 y2 parallel to this face A edge view over here, and having drawn this AIP, I need to project all the 4 points which are lying onto this edge view on this auxiliary inclined plane, and the corresponding projections which will be obtained through the auxiliary right hand side view. So these projections, they are going to provide us with the true shape of this surface which is the surface A over here. Now let us mark the different points which are lying onto the surface A. So I have marked these points as 1 double dash, 2 double dash, 3 double dash and 4 double dash. So these are the 4 points which are projected onto the profile plane. So this is the point 1, this is the point 2, this is the point 3 and this is the point 4. Now having marked these 4 points corresponding to the face A on the right hand side view, let us mark these points onto the isometric projections of the solid. So this is my point 1 which is corresponding to this point 1 double dash. This is point 2. So over here this is point 3 that we have. This is the point 4. Now we have got the marking of all these 4 points in the right hand side view as well as in the isometric projections. Now let us evaluate these 4 points in the front view construction of the solid. So when we are going to look at the solid from the front side, points 4 and 1, they are going to coincide at this particular position. Similarly, when we look at this from the right hand side, points 3 and 2, so they will be projected over here. So points 3 and 2 over here, they will be projected at this point in the orthographic front view projection. So we can check 3 dash and 2 dash, they will be appearing here. 4 dash and 1 dash, these are another couple of points which are projected over here. Now using the projections from these 4 points 1 dash, 4 dash, 3 dash and 2 dash onto the auxiliary inclined plane, we are going to evaluate the true shape of this inclined section surface over here. Now we know that the distance between this particular point 2 double dash and the point 1 double dash from the x1 y1 reference plane over here. So this distance we have taken as arbitrary distance. Reason, this distance is arbitrary. So this distance, it was not provided to us. So there was a flexibility to choose this distance as per our convenience. So this distance is an additional distance which we have to take care of. So we can say that the total distance of this point, otherwise usually we are taking this distance as x and then we can say this is x plus 55. But now since we have to evaluate the true shape corresponding to these 4 points, now I am going to assume that this total distance from this x1 y1 reference plane happens to be distance x over here. So I am going to mark this distance of distance x corresponding to the points 2 double dash and 1 double dash onto these auxiliary projections over here. Now this distance x I am going to mark over here in the auxiliary side view projections, and once I mark this distance x, now 2 points, one over here and one over here, I will be able to obtain. So here which point will be obtained? So I can check that this projection line has been drawn from the point 2 dash. So alongside this projection line which is corresponding to the point 2 dash, so ahead of this AIP, I have marked this distance as distance x over here. So here I am able to obtain the point 2 1 double dash over here. Similarly, the same distance is going to provide me with the location of the point 1 double dash over here, because this projection line has been drawn corresponding to the point 1 dash over here. So point 1 double dash will be obtained over here and point 2 1 double dash will be obtained over here. So the 2 points of this inclined surface A have been obtained. Now in order to obtain the remaining 2 points, so we know that the distance of point 3 double dash and 4 double dash from this x1 y1 reference plane, it happens to be x millimeter plus 25 millimeter. So now we are going to draw a distance of 25 millimeter ahead of this distance x, right? So ahead of this distance x, I have marked another 25 millimeter distance, and the moment I draw or mark this 25 millimeter distance, I am able to obtain the remaining 2 points corresponding to this rectangular surface. Let us work out which point will be obtained over here. So since we have seen that this projection line has been drawn corresponding to the point 3, that is 3 dash over here, so we will be able to obtain the point 3 1 double dash at this particular location. So this is the location of the point 3 1 double dash. Similarly, this is the location of the point 4 1 double dash. So with this we have identified all the 4 points corresponding to the face A in the auxiliary right side view. So since we had drawn this auxiliary inclined plane parallel to the edge view of this sectioned inclined surface of the solid, so we are able to obtain the true shape in the auxiliary right hand side view. So this is the auxiliary right hand side view projection of this particular surface A. This is the inclined section surface for which we were required to evaluate the true shape. Now we can check if I compare this true shape with the original apparent shape which was obtained by me in the right hand side view. So we observe that this apparent shape, this is much smaller than this true shape of the face A. So we can conclude over here that by drawing an auxiliary inclined plane parallel to the sectioned face over here. So this is the sectioned inclined surface of the solid which has been cut by an inclined plane. So if we draw an auxiliary inclined plane parallel to this inclined section surface A, so the projections of this surface onto this AIP will be providing us with the true shape. So this is the procedure for evaluation of the true shape of the sectioned inclined cut surface of the solid using the auxiliary plane method. So this is all for today. So we'll be continuing with further discussions on few more illustrations regarding the applications of the auxiliary plane in the coming lectures. So thank you very much. Thanks a lot.